What is scientific research really like? What follows is the lowdown on scientific research. Scientific research in a nutshell. Science education is about what is known, about what has been generally accepted as our current best understanding of broad areas of science. Some educators write textbooks, prepare and give lectures, and devise laboratory experiments. Many scientists, shortly after receiving their doctoral degree, become full-time educators. Others split their time between education and research, and a few devote all of their time to research. Scientific research explores the unknown at the frontiers of human knowledge. Theorists develop explanatory models based on empirical evidence. Observationalists not only provide theorists with the data they need to formulate their theories, but actively seek to make observations that test the theories, possibly bringing currently accepted theories into question or even invalidating them, forcing the theorists to devise new and hopefully better theories. Unlike science education, which topic-wise is very broad, scientific research projects are sharply focused on one narrow topic at the frontier of knowledge. The activities of scientists include preparing research proposals, conducting the research itself, writing papers on the research results for publication, refereeing other scientists' proposals and papers, and attending conferences to present papers, listen to other papers, and informally discuss the latest happenings in a research area. Good students learn early on how to succeed in the education game. They learn how the game is played, understand the rules of the game, and how to abide by them. The scientific research game is very different from the education game. The rules are quite different. If you want to succeed in scientific research, you should not only know the rules, but understand the reasons behind the rules. The normal classroom rules do not apply to scientific research. For instance, it is not individual student learning that counts, except as required to prepare to be an effective team member. Rather, it is the quality of the team's research and its published paper that counts. The scientific research process. Form a research team. Pick a suitable topic and prepare a research proposal. Submit the proposal for consideration. If approved, conduct your research. Write a paper that describes your research and its results. Send the paper out for external review and incorporate any suggestions. Submit your paper to a journal for their consideration. Rewrite your paper to accommodate suggestions by an anonymous referee. Submit your final paper for publication. Present your results as a talk or poster at a conference. Teamwork in scientific research. Most scientific research is a team activity. Teams often include scientists from several disciplines, mathematicians who work on data analysis, engineers who design the instrumentation, and a diverse supporting staff which takes care of many other matters. Unlike a typical classroom project, equal participation by team members is not expected or even desired. In research, each team member contributes as their time, interest, and capabilities dictate. Justice with respect to the degree of team member contributions to the project is handled via author order in the final paper. Also, unlike a classroom project, researchers from other institutions often join a team to provide additional expertise and help further the goals of producing a high-quality contribution to scientific knowledge. All significant contributors to the project should be included as co-authors of the paper. If an instructor makes a significant contribution, as they often do, then they should also be included as a co-author. If researchers outside of the school significantly contribute to the project, as is hopefully often the case, they too should also be included as co-authors. Published papers are the visible product of scientific research. However, it is not unusual for as much effort to be put into writing and reviewing a proposal for a research project as is placed into writing and reviewing the paper that results from the research. For most professional scientists, proposals are the primary avenue for requesting and receiving the funding that will pay for the research. Without funding, most professional research is not possible. Soliciting confidential external reviews by a number of experts prior to the submission of a proposal, and closely following their advice will greatly increase the chances of the proposal's approval. It is not unusual that one or more of these reviewers will also be on the panel that decides the fate of the proposal. Soliciting confidential external reviews by a number of experts prior to the submission process of a proposal and closely following their advice will greatly increase the chances of a proposal's approval. It is not unusual that one or more of these reviewers will be on the panel that decides the fate of the proposal. Most professional research proposals are reviewed by institutional research supervisors. Proposals that survive this review process are often submitted after appropriate revision to governmental funding agencies such as the National Science Foundation or NASA, or to private funding foundations such as the W.M. Keck Foundation. These agencies typically have anonymous panels of expert reviewers that rank proposals. Only the highest ranked proposals are funded. The majority of proposals are not funded. It is unusual to have a research project funded the first time it is proposed. However, if the feedback from the reviewers at the funding agency is taken to heart, the chances for success on the next submission will be improved. The proposals should address these critical topics. What is the question, issue, or controversy that the proposed research will address? Why is the research important? What exactly will the research project accomplish and how will it be done? What are the methods, instrumentation, costs, and schedules? How will the project yield a better understanding of the subject? In the case of student research projects, there usually isn't a requirement for funding, and thus the proposal preparation process may be simplified. That said, preparing a good written proposal is a vital element of any research project. It forces the researcher to clearly establish the purpose, goals, methods, and feasibility of the project before the research is undertaken. You probably learned about the scientific method in high school, the perfectly choreographed process of stating a hypothesis, performing an experiment to test the hypothesis, and drawing conclusions about the validity or lack thereof of the hypothesis. This is a valid method for hypothesis testing, which is critical in some areas of research, such as drug safety and efficacy. However, not all scientific research follows this textbook method because not all questions are amenable to hypothesis testing. For example, there are many critical constants in the sciences, such as the charge of an electron, the gravitational constant, and the astronomical unit. If your goal is to improve the accuracy of one of these values, then your job is not to test a hypothesis. Rather, it is to make a more accurate measurement. Similarly, there are a variety of other research areas where there are many unknowns, and the goal of a research project is to discover the properties of some object or phenomenon. Often this requires making many observations over time or spread out over some geographical area. Research teams, often over several years, make the necessary observations and report them in published papers. Later on, some theorist will pull all the published observations together, try to fit them to an established model, or if the fit is not good, develop a new model or even a new theory. Our scientific understanding of the natural world would not advance if scientists did not share their discoveries with each other. To encourage the sharing of discoveries, science has a very strict rule. The first to publish receives the credit for the discovery, not the first to make the discovery. When scientists discover something new, they are often torn between refining their discovery with further research before they publish it so it can be presented as a solid, well-documented discovery, versus publishing it right away in a rough form so they won't be scooped by someone else. Fast publication, however, may risk tarnishing their reputation by presenting premature or even incorrect conclusions. To avoid unreliable results, scientists are required to describe their methods and results in published papers in sufficient detail so that other scientists could replicate what is being reported. Attempts to replicate observations are very likely if the results being reported are unusual or groundbreaking. To keep unreliable results from being published, most journals require that anonymous expert referees critique papers prior to their acceptance for publication. The referees suggest to the paper's authors how their paper should be improved to bring it up to generally recognized standards for research in this particular area. Often, the paper's authors are required to respond to the referee's suggestions point by point and explain how they have met the referee's suggestions, or alternatively, explaining why they feel the referee's request was inappropriate. There is a hierarchy of scientific research journals. Papers should be submitted to the level of journal appropriate to the research being reported. Major new discoveries are often reported in Nature or Science. Routine observations are reported in much lower level journals that are typically specialized in some rather narrow area of science. Submission of routine but valuable observations to a high-level journal would only result in rejection and hence a delay in publication in a more appropriate journal. On the other hand, submitting a breakthrough discovery to a low-level journal would lessen its impact and slow its acceptance. Scientific papers, including papers reporting observations, follow a fairly standard format. Introduction, experimental or observational methods, results, discussion, and conclusions. A title and short abstract precede the body of the paper, while acknowledgments and references wrap up the paper. Papers should discuss and cite previous related research. This not only places the current research into context, but it provides proper credit to previous researchers. Citing the papers of previous researchers can improve their citation index, a measure of how widely the scientific community values their contribution to the common good. Appropriate references in a paper can strengthen friendships, while failure to include such references can dampen friendships. Papers should be both concise and precise. Needless or flowery wording should be eliminated. One of the hallmarks of scientific reporting is objectivity, often testable hypotheses, verifiable experiments, or observations. Appeals to authority, revelation, politics, or emotions are strongly discouraged. Papers should not be sent out for external review until they have been neatly formatted, edited to produce the best possible paper, and have been carefully checked for spelling, grammatical, or other English errors. For all researchers, but especially for novice researchers, it is good practice to send a paper out for external review on your own volition prior to submitting it for publication, where the journal will select an anonymous expert referee. It helps to thank these reviewers in your acknowledgments. This will add gravitas to your paper. Highly critical external reviewers and anonymous referees are your friends. Pay close attention to their suggestions. Your reputation and those of your co-authors, that of the participating institutions, and the journal your paper will be published in all depend on the quality and correctness of your published paper. Develop a positive attitude toward critical reviewers. Learn to seek them out and welcome them. They are your friends. Most conferences and workshops tend to be specialized, focusing on one area of research. However, there are also wide across an entire discipline conferences attended by thousands or tens of thousands of scientists. Both are valuable. While published papers are central to the scientific research process, the greatest actual exchange of information between scientists occurs at conferences and workshops. Presentations by the researchers themselves give life and additional meaning to the research. Informal discussions illuminate murky or difficult areas of research. Friendships are made at these in-person gatherings, often for a lifetime. Perhaps of greatest importance, partnerships for new research projects are struck at the bar after dinner. Student research presentations are very welcome at most scientific conferences and often receive special considerations such as modest funding to help defray travel expenses. After all, the professionals at the conference were all once students themselves. Giving a presentation and interacting with professional scientists at a conference can be a valuable and eye-opening student experience. For all of the care that scientists and reviewers take, science is still a messy business. The scientific frontier is an uncertain place. Methods may have hidden flaws, conceptual errors are not infrequent, chance effects may obscure real causes, and a few frauds and incompetence will sometimes slip one over on the rest of us. One generation's conventional wisdom may be overturned by developments in the next generation. Occasionally, whole fields turn out to be flawed and have to be written off. Scientists try to be skeptical of even accepted ideas, but excessive skepticism leads to paralysis. Science is an adventure, not a theme park ride. Real research is not a laboratory exercise with a well-known clean outcome. Science is a project done by fallible humans. Don't expect perfection.